All right, here we go. Chapter 2. This is Kinesiology 230. We're at Chapter 2, Structure and Function of the Cardiorespiratory System. This is Presentation 1 out of 6, I believe. We're going to have a quick overview, and then we're going to talk a little bit about cardiovascular anatomy and physiology as we go through these presentations. All right, so the chapter itself, these are the main points that we're going to go over. Describe the anatomical and physiological characteristics of the cardiovascular system, describe the electrical conduction system, what it looks like in a basic ECG, some of the way blood is controlled throughout the body, and some of the anatomical and physiological characteristics of the respiratory system, et cetera, et cetera. We're going to hit pretty much all of these, no doubt about it. So if we take a look at like a rough outline, how I'm laying this out over the next couple slides. You have cardiovascular anatomy, physiology starting on 15, and then we go into oxygen transport. We'll talk about oxyhemoglobin, dissociation curve, talk about cardiac morphology, electrocardiogram, et cetera, et cetera, et cetera. And we'll get into the respiratory system down here on page 21, which is going to include the structure, different volumes within the lungs, how gas is exchanged, and then oxygen uptake. All right, so the cardiovascular and pulmonary systems, if we take those two words, cardiovascular and pulmonary, you look at the whole system that is, you have this whole circulatory system that happens in the body, and it's partially the heart, which is the pump, the lungs, which is where part of the oxygen exchange and CO2 exchange happens, and then also down in the capillaries in the muscles where you have the oxygen and CO2 exchange happens. And I like this little bullet point the book gives here. You look at it, it serves different purposes in terms of it delivers important nutrients to the functioning tissues, but also removes byproducts. I think you need to kind of wrap yourself and give this little passage here a big embrace because you're going to see it somewhere else for sure. But the cardiorespiratory system is different than the cardiovascular system. The cardiorespiratory system is inclusive of the lungs, where the cardiovascular system is not inclusive of the lungs. So if you look at this, you go, these are the lungs up top here. This whole picture would be the cardiorespiratory system top to bottom. If we just do and cover the top part of this top part of the slide over here to the right, everything from the heart down would be the cardiovascular system. Cardio, right? Cardio like heart. And then vascular would be vascular system. And then cardiopulmonary, lungs, that would be inclusive of the lungs because of the terminology pulmonary. All right, guys, got it? Gonna jump into the next one. Very, very loosely kind of explained here. And this is the way I describe it to like my clients when they're kind of winded. And I describe to them the process of why they're winded and when they're working out. The whole system itself can be kind of compared to the L and the Metro train system, though the cardiorespiratory system itself is a closed loop system, delivering blood out and returning and receiving blood back. But the way I describe it to my clients is the red line, which is not, blood is red no matter what, but the red line takes oxygenated blood away from the heart out to service the muscles in the body. And while it's doing that, the people who are the passengers of the red line, the red blood cells, are jumping off, and then blue are jumping on. So it's this constant jumping off of red, jumping on of blue, jumping off of red, jumping on of blue. And that changes our partial pressure in terms of the oxygen concentration of the blood. And that's where we get the terminology red blood, blue blood. And blue, when it gets back to the right atrium of the heart, has the lowest concentration of oxygen, whereas when it leaves the left ventricle over here, it has the highest concentration of oxygen. So this whole system, this closed loop system, as it's leaving, servicing, going to the heart over to the lungs back to the heart, back out to the body. It's this constant jumping off and jumping on of red passengers and blue passengers. In essence, what it is, it's a constant jumping on of oxygen in the lungs, and then a constant jumping off of oxygen through the system, and then jumping on of CO2 as it makes its way back to the heart and then to the lungs for oxygen CO2 exchange yet again across the membrane in the alveoli. So a couple things going on there. It's a pretty complex system, but when you're working with clients or people have like a burning sensation because you're working them a little bit too hard and their lungs are kind of roasting and their legs are burning, you have to describe it in real simple terms. Like, here's what's going on. Your body's trying to service the muscles, but it's also trying to blow off CO2. So make sure we have some kind of active recovery to help you blow off CO2, and we can create more ATP, et cetera. So there's a lot more that goes into that conversation you have with clients. But the big one and the big takeaway I always have with our with clients on the front end is red line, blue line, red line, blue line, and just reinforcing that over and over. So with this, blood is comprised of different components. You have plasma, erythrocytes, leukocytes, and platelets. And so it's really almost majority plasma and erythrocytes. And the blood acidity is about 7.4. And it's buffered through a number of different systems, but particularly bicarbonate and just ventilation and kidney function. As I mentioned, the blood makes its way back to the lungs. We're blowing off CO2. That helps change the acidity of the blood itself. Goes back and returns to the body. There's a point where when you're working so hard, the body just can't keep up, and the blood becomes more acidic and more acidic and more acidic, and that becomes a limiting factor in contraction. But realize this is our key right here, and we'll see later in another presentation regarding oxyhemoglobin dissociation curve at 7.4, and depending how our body responds in terms of exercise and how acidic the blood is or alkalytic the blood is, depends how that curve shifts. But just kind of keep this in mind. Our blood is plasma, erythrocytes, and to a very small degree, leukocytes and platelets. I'm going to jump out of this and get into the next one. Guys, hold on.